Hi everyone. Take maybe 20 seconds to read the problems, and after we're gonna start. Okay, so first we need to state the null hypothesis and the alternative hypothesis. So first remember that the null hypothesis is denoted by HO, and it is a tentative assumption about a population parameter. The alternative hypothesis is denoted by HA, and it is the opposite of what is stated in the null hypothesis. So in this case, they want to see if the number of houses sold in Montreal is less than 105. But they stated in their problem that the number of houses sold in Canada is 105. So we stated the assumption, and we stated what we want to prove. Here I wrote the mean. They gave us the mean, which is 95.53 days. We have the standard deviation and our n. So the second step is to always draw a curve, and in this case, in the problems, they told us that it is normally distributed. So I already did it here. I remember that they told us in the question, in the question over here, that the level of significance is 0.01, and our degree, our df is 15 minus 1. Our degree of freedom, in this case it's 15 minus 1. So it's always k minus 1 or n minus 1 in this case. So it's 14. So we see here that what we need to look for, it's t, level of significance 0.01 and degree of freedom of 14. So the third step, to find our critical value, we need to take our table, our t table just over here, and we need to check for a level of significance of 0.01, which in this case it's this one, and we need to check for a degree of freedom of 14. So in this case, we have this number over here. Okay, so this is our critical value. So here we find our critical value, and because it is minus, we will have a minus over here. So the fourth step is to find the test statistic. To find out the test statistic, we will use this formula over here. So we're gonna plug in our numbers. That's why I drew these little circles to help us. And after, you're gonna use your calculator and calculate. And it gives us minus 2.383. So we have our test statistic we just found, and we have our critical value that we found in our table just over here. So the last steps, we need to see if we reject or not the null hypothesis, which we remember, it's this one. So to see if we reject or not, it is important to understand that we reject only if the test statistic is greater than the critical value. And remember to always put your bracket, and by putting our bracket, we're gonna always take the positive number, and in this case we have 2.383 is greater than 2.624. So we don't take the negative value, we take its absolute value, and in this case it is not greater. Thus, we do not reject HO at a level of significance of 0.01. And if we look at the second question over here, will the conclusion you made in part A change if the significance level is changed to 0.05? We can do it now. Yes, of course it changed, because here your critical value will change. It will be T 0.05 and degrees of freedom of 14. But the value in our T table will be different, of course, of this one, because the level of significance changed. So if we take a look, we're gonna go in T 0.05. We're gonna look at 14. 14 is this one. So 1.71. Sorry, I'm French. 1.761. So of course you can see that the number is different. We didn't get the same number. And if we're gonna have the same test statistic, the number here doesn't change. But when we will check if we reject or not, it's gonna change, because remember, it's always absolute value of the test and absolute value of the critical values. So in this case, it is still 2.83 greater than 1.761. And in this case, it is true that the test statistic is greater than the critical value. So our conclusion, we reject HO at 0. Okay, so to answer our question here, our conclusion will change if the level of significance is 0.05 instead of 0.01.